What's going on, guys? Welcome back to this video. Today we're going to discuss or talk about firewall evasion. Before we start digging deep into the tactics or techniques used to evade firewalls, let's first explore the types or the most common types of firewalls used today. The first type of firewalls is the stateless. So as the name suggests, the stateless firewall doesn't keep track of the status of the connection. So you could be establishing TCP, or you could be establishing a UDP connection. The thing is, stateless firewalls doesn't keep track of the connection. Therefore, it cannot detect whether a packet is outside of the connection. So usually the highlighted feature of stateless firewalls is that it is able to filter packets based on 4 attributes. First attribute is the source IP. The second is destination IP. The third attribute is the what happened? Okay. The third attribute is the source port. And finally, the destination port. So usually a firewall filters packets based on rules, a set of rules. Stateless firewalls can actually be configured with rules to detect or filter packets based on these attributes, to allow or deny. Okay. Now the next type of firewalls is the stateful. Now, stateful firewalls have the same features as stateless, meaning they detect the packet or they filter packets based on these attributes. But on top of that, stateful firewalls are able to track the state of the connection. It can detect wrong packets or packets outside of the connection. The third type of the firewalls is the proxy firewalls. So proxy firewalls, most commonly seen as WAF. WAF is Web App Firewall. Usually, web application firewalls or proxy firewalls, they sit between the client and the server in the middle and intercept requests, making sure that the web server is protected against most common attacks. An example of WAF most popular used today is the WordFence. You can see WordFence installed on WordPress content management systems or WordPress-based websites. All right, and lastly, it is the NGFW, next generation firewalls. Next generation firewalls are the most common firewalls today seen in corporates and networks. Usually, next generation firewalls, they actually have more capabilities than stateless, stateful, and proxy firewalls combined. In that, proxy firewall, NGFW firewall can inspect the application layer. Remember, in the OSI model, we had at the top the app layer, okay, session, presentation, all the way down to the data link. So basically, the next generation firewalls can detect and inspect the application data. Meaning, for example, let's take an example. We have a DNS packet. Or let's take another example, HTTP packet. Okay. Usually, if it was stateful or stateless firewalls, it's going to detect the source IP, the source port. It's going also to see that the packet is destined to port 80 and the server IP. That's for the stateless. Now with next generation firewalls, the firewalls are able also to inspect the payload data, meaning it can take a look at, or it can inspect the request, get request, post request, And if there is any clear text data, such as the URL, the page name whatsoever, the credentials, all can be detected and inspected by next generation firewalls. And also they have capabilities to act as intrusion prevention systems. Okay. All right, so now having stated the types of firewalls, let's now talk about firewall evasion and why sometimes we need to learn the tactics of firewall evasion. First thing, let's understand the purpose of firewall evasion. All right, so usually in red team engagements, okay, I'm gonna end the word. So in red team engagements, we go through the phases the attacker actually goes through when we conduct the attack. So first we start with the recon, and then after gathering information, we start to weaponize the payload. After preparing the payload, we then deliver the payload through the appropriate method or the appropriate medium of communication. And then if the user clicked on the link, or if the exploitation was successful, now we got access to the target, and now we start to install malwares, install backdoors, startup scripts to maintain access. Then we start the actions on objectives. That's the usual cyber kill chain. Now, firewall evasion tactics mostly are needed when we conduct reconnaissance or when we actually deliver the payload. Let's take a scenario. So let's say here there's a firewall here. Yeah. Okay. So we have a firewall here. Okay, let's say it's NGFW. And behind this firewall there is a web server. And there is, let's say, a database server. Okay, and here we have the internet. Let's say on the internet side we have the attacker. Now, as an attacker, you are interested in, let's say your target here is the web server. This is the target. We want to get access to the web server so that we can move laterally and exploit or gain access to the database server to download the database that holds all the enterprise data. So here, as an attacker, we start first with the recon, beginning with nmap scan. Alright, so here's this thing. With nmap scan, you want to detect the available open ports and the services running on the network. But the thing is, the firewall might prevent you or might detect that you are scanning with nmap, and thus when you run nmap scan, it will deliver zero or meaningless results. So that's an example where you need to learn how to trick this firewall so that our nmap probes pass and return the available open ports. So if web server was exposed, it's going to be running on port 80, and the DB server might be running on port, it could be 888 or 8008. So here is an example where you need to learn how to evade the firewall. Another example is through the delivery phase. So here, say that with firewall evasion, you will be able to, or you are able to scan the target, and you detected port 80 and port 8008. Alright, so you have interacted with the web server running on port 80, and you have found a vulnerability. Now it's time to exploit this vulnerability. So in order to exploit the vulnerability and get reverse shell, you found that you need to create a netcat session. Okay, so let's say here there is you found a way to execute remote code, and then on the web server, so that the web server will interact with the listener running on your machine. So here you needed to, for example, on your machine, attacker machine, you run the command nc-l-nvp and you use the port 4546. All right. So once you found the exploit, now you are actually going to exploit a remote system command. So in order to connect to your listener running on your machine, you will have to execute nc, your IP address, and the port 4546. Now the thing is, the firewall might block the connection using this port. So what you are doing here, you are instructing the web server, okay, to connect to your machine on port 4546. So the firewall might prevent this connection from taking place. So here is another scenario where you need to evade the firewall. And lastly, when you want to exfiltrate data, meaning actions on objective. So let's say you have got access now to the DB server and you found sensitive files with the extension zip. Okay, now you want to smuggle the data to your attacker machine. So one of the methods you could do that, you could use netcat. You could use another file transfer method such as FTP. You could be running FTP server on your machine and then you run FTP command on the database server to transfer data. But again, the firewall might be blocking the outgoing connections on these ports. Now, this is another scenario where you need to learn how to evade the firewall. Let's start now with a scenario. Let's start with a tactic proven to evade the firewall during the reconnaissance phase. We're going to do this with nmap. So now let's talk about firewall evasion, okay, with nmap. The first tactic we can deploy is decoy scan. A decoy scan is where nmap uses several different IP addresses to scan the target. Let's take an example. So nmap, okay, let's say we are conducting a scan to reveal the services. We disable ping probes, and then to use decoy scan, we use the -d switch, and then we list the IP addresses. Now, actually the choice of these IP addresses relies solely on you. You can choose whatever you want. You can write 10.0.0.1. The IPs will be separated by a comma. 10.0.0.2, and here then it's imperative that at the end, not at the end, somehow you need to put the IP address here, and then you continue the list. You can choose as much as you want. You can choose to scan or send the scan packets using 3 IPs. It could be 2 IPs, it could be 100 IPs. And then, so we chose 3 IP addresses, okay, to scan from, and then here we input the IP address of the target. So that's an example command. So what's the purpose of this, or using the decoy scan? Here, we are actually obfuscating the real identity of the attacker. Sometimes when you scan with nmap, and let's say the firewall has detected nmap scans, it's going to block your IP address, so that next time when you try to scan, you're not going to be able to have any success. That's why we use decoy scans. We confuse the firewall, and even we confuse the blue team, okay, who are actually monitoring the network. They will see many probes coming from many different IP addresses. They will not be able to know who is the real attacker, what is the real IP address of the attacker machine, so they can block it. Now, one option you can do as a blue teamer is to block all the IP addresses. Again, the attacker can choose another list of IP addresses and scan with it. For example, if you are concerned about what IP addresses or which IP address to choose, you can let nmap do the work for you. So another variation of this command could be, that's one. 2 is, let's say, nmap -sv -pn and then -d for decoys. So we choose here R and D. randomize the first IP address. Then here we put our real IP address. Okay, so here real meaning your IP address, but don't use the word real in your command. And then R&D, and the list goes on. This way, nmap will, with every scan you conduct, with every command you execute, nmap will generate different IP addresses. Okay, so that's the first method of evading evading the firewall. Okay, next, if you don't want to use the decoys, you can choose to scan nmap using a proxy. So how does it accomplish? You can type nmap dash, let's say the same command, sv dash pn, and then you could use the word or the switch dash proxies, and here you put the proxy URL. It could be a URL or it could be a single IP address. You can put the IP address of the proxy, or if it was running on SOCKS 5 or HTTP proxy, you can put the URL. And then next you put the IP address of the target. So what's going to happen here? Again, similar to decoys, the scans will appear as if it is coming from the proxy URL, not your real attacker IP address. This way you hide your real identity, which is very useful if you want to avoid being blocked. So the thing is about firewall evasion, it's not going to be successful from the first attempt. Most importantly is to hide your real IP address. You don't want to be blocked, because if the firewall blocks the original IP address, you're not going to be able to scan again. Okay, so now let's go to and start let's go talk about the third method. It is spoofed IP address. So up until now, we are hiding our identity. So let's say you know a reliable IP address on your network or somehow on the internet under your control. You can choose to scan from this IP address. So you can use the switch dash S uppercase, and here goes the IP address. This way your nmap scans will appear as if it is coming from this IP address. Very useful if you want to hide your identity again. Fourth tactic here is to use fixed source port, meaning we conduct our scans and let it appear as if it is coming from a fixed port number. So why do we use this method? We use this method if we are sure that the firewall allows incoming packets from a specific port number. Okay. For example, let's go back to the first scenario. So back to this network here. In this network, we learned that there is a next generation firewall, and behind this firewall there is the web server running on port 80 and DB server running on port 8008. In order for the web server and the DB server to serve requests from the internet, specifically the clients, the next generation firewall will need to allow incoming packets on these ports. So now we can use these ports to perform nmap scan. That's the trick here. But how do we do that? It's very simple. We can write a sample command, nmap, and then dash s, let's say v, which is a very noisy scan by the way, dash pn, and then we use the switch dash g, and then we put the port number that we think we have confirmed it is allowed to pass through the firewall. Let's say it is 8008, followed by the IP address of the target machine. This way we make our nmap packets appear as if it is coming through this port. Okay, definitely it's gonna pass through the firewall and give us meaningful results about the network topology. The fifth method is controlling the data length and the fragmentation. Okay, so what do we mean by fragmentation? Fragmentation is dividing the packets into multiple of 8s. So let's say a packet here, let's say it has the size of whatever, 164. So when you fragment the packet, the firewall at the end here, ngfw, let's say, okay, we receive the packets in batches. So we divide the full packet into multiples of 8. So it will be group 1, group 2, group 3, group 4. What's going to happen here, the firewall will not receive the full packet. It's going to receive the packet in batches. So the first packet comes in, the firewalls pass it through, then the second packet comes in, the firewall passes it through, and then when all the packets pass through the firewall, 1, 2, 3, 4, they will all be reassembled into the original packet by the host. The host is the target of our scan. In that case, it was the web server. When this can be successful, it is when the next generation firewall or the IDS don't reassemble the packets. Meaning, the packets here come in fragments. Fragment 1, 2, 3, 4. The next generation firewall, if it doesn't reassemble the packets, it's going to allow the fragments to come or to pass through. And then the web server, in turn, will reassemble all the packets into or to form the final original packet that was sent. This works, but if the IDS has capabilities of reassembling the packet as the web server, it's not going to work. But how to do it? You can do that with nmap. Nmap, let's say -s for stealth scan -pn, and then -f, lowercase f, the IP address. Using this option, what's going to happen here? The nmap is going to send the packet into multiple packets, with each has the size of 8 bytes. Meaning packet 1 will be 8 bytes, 2, 8 bytes, 8, a multiple of 8s. If you want to control the size of the packet, let's say there are multiple of 16, then you can use -f. 2 Fs will send the packets where each packet has 16 bytes of size. Here you can control the size of the packet. And lastly, we can control the scan or control the length of the data in the scan. This can be accomplished using another switch, nmap dash, let's say ss dash pn, and then we use the switch dash dash data dash length. So while we sometimes choose to set a customized data length for the packets, because some firewalls or IPSs are configured to detect certain sizes and block the packet entirely. That's why sometimes you want to control the size of the packet. You can do that using dash 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 length, and then you can put the desired size. Let's say it is 128. You also choose 64. Now this can be accomplished using the switch dash dash bad sum. For example, nmap dash sv dash pn dash dash bad sum, and then the IP. But this is not a reliable way to scan the target. Sometimes it won't return meaningful results. So here it's either it's up to the end that will receive the scans. So let's say you have executed this command and the ngfw picked up the packet. It depends now on the ngfw. Some firewalls or intrusion detection systems will detect that the checksum of the packet is invalid, and then what's gonna happen, if it detects that, it's gonna drop. And if it drops the packet, you will have 0 results, meaning no, you're not gonna have information about the open ports. But some firewalls will ignore the wrong checksum and give you the allow the packet to pass through. And the last method now we're going to talk about, which is a very popular method, is port tunneling. Sometimes it's called port forwarding. Now, this is mostly useful when you are doing lateral movement. Let's give a scenario. So, here you are. I'm bad at drawing. So, the attacker, and you are evil, like this. And then what you are doing here, there is a network behind a firewall. Inside the network there is DB server, there is a web server, and let's say there is email server. Okay, now as an attacker, what you did, you scanned the network, you found that there is open port on database server 8008, web server running on port 80, and email server running on port 25. Alright, so you have done your homework, you have conducted an nmap scan, you have conducted reconnaissance, you found that there is a vulnerability in the web server. You have exploited the vulnerability, and now you got access here, so you are here. Okay, fine. What does that mean? It means that we are sure that now the firewall allows incoming packets on port 80. That's how we were able to exploit the web server. But now we have discovered that the firewall doesn't allow packets to port 25. Meaning, if we want to interact or exploit the email server, the firewall will block all the packets coming to port 25. It's gonna drop them. So you cannot now try or even attempt to interact with the email server from outside the network. So you decided to choose your current position from the inside, because you have got access to the web server to interact with the email server. But you don't want to do that from the web server. You want to do it from your machine. Okay. In that case, you need to do port tunneling or port forwarding. You can do that using SSH. Or you can also use Ncat. So now this is the web server. And now as an attacker, here, you are executing system commands and you have full control over the web server. Okay. Now there is the email server here, running on port 25, we said, and it's running on port 80. Now you are here, there is a version of you here, and there is a version of you here outside the network, cloud. Okay, you want to interact with the email server or try to exploit it not from your version here, which is internal, but from your version that is sitting outside the network. So what you're going to do, an example is using Ncat. So on the web server, you're going to execute the following command: nc, okay, -lvmp. You create a listener on port maybe 80, and then -c. From here, you're going to forward or execute a command that will forward all the incoming packets to port 80, will go to port 25. Here, your main command will be, let's choose this color here, nc again, the target IP address of the email server. So here goes IP and 25. That's the command. Where you're going to execute this command, you're going to execute this command on the web server. You have now RCE, you put this command here, and then you're going to your version which is sitting outside on your machine. You're going to type nc, and guess what? You're going to put the IP address of the web server and port 80. So what happens here, you're connecting to the web server running on port 80, and since there is a command on the web server or a listener listening on port 80, it's going to catch the connection and forward it to the email server. Therefore, you are able to interact with the email server. The other method is using SSH or SSH port forwarding. There are multiple types of SSH port forwarding, but that depends heavily on the environment. It's not a one-size-fits-all. If you want to use SSH port forwarding, the web server here, or the server, whatever it is, you should have SSH access to it. So back again to the same scenario. There is a firewall here, and behind the firewall there are multiple clients, PC1, PC2, PC3. And you are here. What you want to do, you want to let's say get access to, or you have access to PC1, but you want to move laterally to PC3. Because there is a firewall, you cannot interact with PC3 from your machine because the firewall will drop. But you were able to get access to PC1 and the firewall, no problem. Okay. So what you want to do here, you want to use PC1, okay, as a pivoting point to get access to PC3 right from your machine. To do that, you can use SSH port forwarding. But one condition is that you should have SSH access to PC1. If you got access to PC1 through a vulnerability in the web server, you should convert from www data into a user, such as maybe a at PC1. Then, using SSH port forwarding, you can now forward the connection. What's the command? So now, given that there is SSH on PC1 and you get access to the user, you can go back now to your machine here and execute the below command, ssh-n-l-0000, meaning any connection coming from any IP. And here comes the port. So what's the allowed port here? The allowed port here, it could be 22, or it could be 8008, any port that's open on PC1. Let's say it's 8008. And then we put the IP address of PC3. And then the port that is running on PC3, let's say it's port 25. We put it here in the command. And lastly, we put the username of PC1, a at PC1 IP address. That's the complete command you want to run on your attacker machine. Now, any connection coming from any source IP address on port 8008 will be forwarded to the IP address on port PC3 running on port 25. After this command is successful, let's say this is terminal 1, you're going to open another terminal, and then you can then use the following command, nc netcat, and then 12001, your local IP address, and then port 25. Now here you are interacting with PC3, but how? This is the proxy here. The proxy is PC1, and because we have got SSH access to it, we can use SSH local port forwarding. So guys, that was all I have to say, or all I got today about firewall evasion tactics. I hope this was all helpful, guys, and hopefully if the channel was not suspended in the upcoming days, I'm gonna see you in the next video.